Alright, ladies and gentlemen, once again we'll be looking at multiplying polynomials. Let's look at some more examples. This is part 2 of multiplying polynomials. Alright, so let's look at some examples here. Let's move this out of the way. Alright, follow along with your handout as well. Right, so we have here example 2. It says a equals to 2 times x minus 7 times 2x plus 1. Right? Now there are different ways in which you can solve this question. Right? You can expand this by multiplying the binomials first and then bringing in the 2 into that product, or you can bring in the 2 here first and then multiply the 2 binomials that are left after that. So let's look at the first method, and then I can show you some common mistakes that happen. Right, so let's start with this. Let's multiply these 2 binomials first. So that means we're doing x times 2x and then x times positive 1, this times that, and this times that. Right, so the 2, we have not touched it yet. Let's leave it there. Alright, open bracket for the product that we're gonna get between these 2 binomials, right? Between the multiplication of these two binomials. So x times 2x gives us 2x squared, right? X times 1 gives us x. We don't write the 1, it's not necessary, but it's implicitly there. Negative 7 times positive 2, negative times positive 2x, negative times positive, negative 7 times 2x, 14x, negative times positive, negative 7 times 1, 7, right? 2x squared, right? Plus x minus 14x, these are like terms, so our answer is going to be negative 13x, and then negative 7, right? Okay, now let's bring in the 2. That means we use the distributive law and we multiply this 2 times each of these terms, right? So 2 times 2x squared gives us 4x squared. Positive times negative, negative 2 times 13x gives us negative 26x. Positive times negative, negative 2 times 7, 14. Right? That's it. There's nothing else we can do. Right, now let's say same example, right? Same example. Let me move this up. Okay, x minus 7 times 2x plus 1, right? So we're using the same example. Let's say that you had decided to bring in the 2 first, right? Like here, 2 times 2x, 2 times negative 7, right? And then that result you would multiply by this binomial. Yes, that would work as well, and as long as we're consistent and we keep track of our results, we should get the same answer. And so let's look at this, right? So let's try it this way first, by bringing in the 2. 2 times x, 2x, right? Positive times negative, negative 2 times 7, 14. Alright, and let's keep this result in brackets. We keep it in brackets because we brought in the 2 into this expression. We're not getting rid of the brackets yet. We can't in any case because the binomial is here. Alright, this other binomial is here. So let's write 2x plus 1. Okay, let's continue. Now we can start expanding by multiplying these 2 binomials. We're very familiar with this already. So 2x times 2x gives us 4x squared, right? 2x times 1, it gives us positive 2x, negative times positive, negative 14 times 2, negative 28x, right? And then negative times positive, negative 14 times 1, negative 14, right? Now, let's collect the like terms. 4x squared. Let me move this up. Right? 4x squared plus 2x minus 28 gives us minus 26x, and then minus 14. Alright, so we're done with these two examples, and as you can see, whether you bring in the 2 first or you expand the binomials at the top here, either way we should get the same answer, right? So these two, this is okay, right? Either method is okay. Either method is okay. Now, I want to show you something before we move on to the next example. These are some common mistakes, so make sure you don't do these. Alright? So, once again, let's start with the same question. Same question. I am simply going to rewrite it, right? This is what ends up happening, especially if you decide, if the student decides to use this second method to bring in the 2 first, right? This is what ends up happening, right? So, for example, let's bring in the 2. The student may decide to do this. Okay, well, 2 times x, 2x, which is fine. 2 times negative 7, negative 14 times 2x plus 1. And then the next line, right? Here's the mistake. Negative times positive, negative 14 times 2x gives us negative 28x. Negative times positive, negative 14. And then they do negative 26x minus 14. Okay? This is wrong, right? Common mistakes, right? Mistakes. So make sure you don't do this, right? This is wrong. This is wrong, alright? Common mistakes. Wrong, alright? Make sure you don't make this mistake. This is wrong. Alright, let's look at some other examples. And then after the first example that we've completed, right, which was this one, the right way, of course, we completed it the right way. You have B, example B there, right? Okay. So example B, right, use what you learned from example 2A, and I want you to complete the rest on your own, and we'll take it up next time. In the meantime, I want to go over this other example, which is, you have example 2C. So example 2C, we have m minus 2 squared minus 3m plus 2 squared, right? So let's look at the following, right? What do we have here? We have a difference of squares. Well, if you're not familiar with factoring, this is essentially what we have. But we have a binomial that is squared minus another binomial that is squared. So let's expand this, right? Great. Let's look at this example. So let's expand these two binomials, right? So, or let's rewrite this expression so that we can better visualize it, right? So this essentially, m minus 2 squared is essentially this, right? M minus 2 times m minus 2, right? Minus, and same thing here, right? 3m plus 2 times 3m plus 2, right? Great. So now, same thing, we expand this and we keep that result in brackets, and we expand this and we keep this result in brackets, especially because there's a minus in front of it. So let's do this expression first. So m times m squared, m times negative 2m, negative 2m, right? Negative 2m times m, negative 2m, and negative times negative, positive, 2 times 2, 4, right? Right, we did this times this times that, right? Now minus, okay, running out of space a little bit. So 3m times 3m gives us 9m squared. 3m times positive 2, it gives us 6m. Positive 2 times 3m gives us 6m, and then positive times positive, 2 times 2, 4. That's it. Perfect. Kind of had to squeeze it in there. Okay, now let's simplify this expression. So m squared Alright, let's simplify this. So you have m squared, right? Any like terms to that? No, so we just leave it. M squared. Negative 2m, negative 2m. So minus 2m gives us minus 4m, and then plus 4, right? And now we have minus 9m squared. No like terms to that one. Plus 6m, that gives us plus 6 plus 6, 12m, and then plus 4, right? Okay. Now we have to take care of this, right? So the brackets, we can get rid of these brackets. Yes, so there's a plus 1 implicitly, so we're bringing the plus 1 into this, and we're getting rid of the brackets, right? So, but essentially, because there's a positive 1, the signs do not change of each of these terms, right? Now, when there's a negative in front, like here, negative in front of this expression, then we have to watch out. One easy way, quick way, would be to simply switch the signs of each of these terms, right? So we end up with minus m squared, minus 12m, minus 4, right? But essentially what we're doing is the minus 1 times each of these terms. So minus 1 times 9m squared gives us minus 9m squared. Negative times positive, negative 12m. Negative times positive, negative 4, right? Let's continue collecting the like terms. So we end up m squared minus 9m squared gives us minus 8m squared, right? We're collecting these two like terms. Any like terms to negative 4m? Yes, then negative 12m. So negative 4m, negative 12m. Minus 4m minus 12m gives us minus 16m. And then plus 4 minus 4 gives us 0, so we don't write it down. And that's it for this question, right? So, and we have example D as well, which is basically this question over here, alright? And here, this is our, right? So same idea, right? This is almost like a combination of the previous examples. You can bring in the 6, then multiply by that binomial, or multiply these two binomials, whatever you like, as long as you're consistent. Same thing here, expand this expression, and then bring in the 3. Okay, whatever you decide, okay, try your best, and we'll take it up next time when we meet.